All right, everybody, we are moving on today. We're going to talk about multiplying radicals. So previously, what we've done is added and subtracted radicals. And before that, we spent some time just like simplifying the radicals so that we would be ready when we needed to add, subtract, and multiply them. So if you remember when we were adding and subtracting, we needed to first simplify and then make sure they had the same index and the same radicand, and then they could be combined. And then we added or subtracted the coefficients. So those are the numbers in front of that radical symbol. And then we kept the common radical. So some things are going to change when we go to multiplying. So make sure that you know how to add and subtract. Multiplying radicals is actually a little bit easier, I think. So the first thing is to multiply the coefficients. So first we want to multiply any numbers that are in front of that radical, which down here we do have some examples of that. So don't get too stressed out. Everything's going to be fine. And then we use the product rule. So when multiplying radicals, you need to make sure that the indexes are still the same. So you are multiplying two square roots together, and that you are multiplying two cubic roots together or two fourth roots together. They always have to be that same index. So if you look at this product rule up here in the corner, it says the nth root of A times the nth root of B. So when we multiply these two things, all we do is multiply what is ever underneath of the radical. So we're just going to be multiplying that A and B. So whatever's underneath of that radical symbol, that's what you multiply together. And then we simply just need to simplify. This is a really important part to make sure that it's in simplest form. So we need to simplify as our final step. So if we look at this first problem here, it's the square root of 27 times the square root of 5. So if you feel like this is something that you want to simplify down and then multiply, you can do that. Or you can just straight up multiply 27 and 5. You'll get the same answer either way. So I'm going to show you both ways, and then you can kind of choose whichever way you want to do it. So this is option number 1. So I'm going to put up here option 1. So option 1 is to go ahead and simplify the square root of 27 times the square root of 5. So 27 has a perfect square that's inside of it, and the perfect square that's inside of 27 is 9. So I can break down 27 into the square root of 9 and the square root of 3. And then we still have it being multiplied by this square root of 5. So we know what the square root of 9 is. That's 3. So the square root of 27 can be broken down into 3, the square root of 3, times the square root of 5. What I'm going to do here is I'm going to add this coefficient of 1 in front, because we can multiply 1 by anything and it's not going to change. I just want you to understand that 1 is kind of that placeholder. If there's nothing in front of the radical, the coefficient is 1. So that first step was to multiply our coefficients together. So we're doing 3 times 1, which doesn't change anything. That's still 3. And then we need to multiply whatever is underneath of our radical. So we're going to do 3 times 5. So I did 3 times 1 first, and now I'm going to do this 3 times this 5. So 3 times 5 is 15. And then we ask ourselves, can this be broken down any further? Is there another perfect square inside of 15? And there's not. So 3 radical 15 is my final answer for this question. If you did it option number 2, so this is, I'll do this in a different color, sorry. This is number 2, option number 2. You can just do 27 times 5, and that gives you the square root of 135, which then you break down into the square root of 9 and the square root of 15. Again, the square root of 9 is 3, square root of 15. So you can do it either way. You can kind of choose whichever way you want to look at it. Sometimes I feel like option 1 is a little bit easier. It makes for a lot less simplifying when you get to the end of it. But if that's just too many steps, you can do it your own way. I am going to do it both ways just for these 4, and then I'll probably just stick to one way over the other. So my option is I'm going to do option number 1 for all of mine, where I simplify and then multiply. But if you would rather multiply and then simplify, totally fine. So again, I'll do both options for the next 4 problems, and then I'm going to switch to just doing option 1. So if I look at number 8 here, it says 3 radical 10 times negative 2 radical 18. So 18 has a perfect square in it, and 18 can be broken down into the square root of 9 and the square root of 2. So what I'm really multiplying here is 3, the square root of 10, times negative 6, the square root of 2, because this one breaks down into 3. And then I multiply the 3 and the negative 2. So these are a little bit easier to multiply then. So when I multiply, I'm going to do my 3 times my negative 6. So I'm doing my coefficients first. So 3 times negative 6, which is negative 18. And then I multiply whatever's underneath of my radical. So 10 times 2, which is 20. Okay, so then I have to think to myself, is there any more simplification that I can do? Can I simplify this any further than I already have? Which I can, because 20 has a perfect square within it. So 20 can be broken down into 4 and 5. So the square root of 4 and the square root of 5. So the square root of 4 comes into 2. So 20 can be 2 the square root of 5. And then I just need to multiply my negative 18 and my 2 to get my final answer of negative 36 the square root of 5. I totally lied to you guys. I said I was going to do both options, but I lied. I think that I'm just going to stick with option 1, just so that we're all kind of uniform across the way that we do it. If I showed you option 2 and you liked it, you can do that. But there's just not a lot of space on here to show you both ways. If you preferred option number 2, you would still multiply those coefficients out front, multiply whatever underneath of the radical, and then simplify from there. I'm kind of simplifying twice because I don't really want to, I don't want to work with huge numbers. I think that's harder for me to remember what those numbers are. So I'm going to keep simplifying and then simplifying again. So I'm going to move on here. Sorry about that switch there. Don't really know what happened. I'm going to move on here to number 9. So I'm going to think to myself, these are both cubic roots. So I'm going to ask myself, are there any cubic roots in either of these two numbers? So there's a cubic root within 24. So negative 24, I can break down into the cubic root of negative 8 and the cubic root of 3. So negative 8 becomes negative 2. And then I just need to multiply my 5 and my negative 2. So what I'm really doing is 2 times the cubic root of 9 times negative 2 times 5. So negative 10, the cubic root of 3. So I'm just going to pause there for a minute. All I did was simplify that cubic root of negative 24. So we worked through those. That's all I did, was just a little bit of simplification. So from here, I'm going to again multiply those coefficients. So I'm going to do 2 times negative 10, my coefficients out front. I'm going to get negative 20. And then I need to do 9 times 3. So 9 times 3, which gives me 27. So I'll have negative 20, the cubic root of 27. Okay. So then I'm going to ask myself, are there any cubic roots in 27? Are there any cubic roots in 27? And 27 actually happens to be a cubic root. If you remember going through all those roots, we did a little bit of that in the first lesson. And the cubic root of 27 is 3. So now I have negative 20 times 3. So negative 20 times 3 is negative 60. So my answer here is negative 60. This is really just about doing a little bit of multiplication and then simplify, simplify, simplify. So let's move on to fourth roots. If we think about our fourth roots and we kind of think about, well, what numbers are in that fourth root category, we're going to think about some of the numbers that go into 64. So if I go through and I check 64, 16 goes into 64, and 16 is a perfect fourth. So I can simplify this guy a little bit. So I still have this -3 out front, and then I have the fourth root of 16. Ooh, that was a bad 6. And the fourth root of 4. So the fourth root of 16 is 2. So what I'm really multiplying together here is -3 times 2, which gives me -6. The fourth root of 4 times, that's a -1 out front there, times the fourth root of 8. So when I do this, I'm going to multiply my numbers out front. So we're going to multiply our coefficients. So that's that -6 times -1, which gives me +6. And then 4 times 8. 4 times 8 gives me 32. And then I ask myself again, are there any perfect fourths that go into 32? Well, we used 16 before, and 16 also goes into 32. So I'm going to break this down into the fourth root of 16 and the fourth root of 2. So the fourth root of 16 is 2. So my final answer here, I multiply, I still have this 6 out front, so I multiply these two guys together, and 6 times 2 is 12. And then I can't simplify the fourth root of 2, so I leave that guy. So today I just wanted to do numbers. So I want to start with practicing numbers. So I gave you 4 different examples here, and I'm going to screenshot these, and they will be on your assignment page for you to re-look over. But we did 4 examples here, and then your homework for the day is just going to be to do 2 problems. I might add a couple more, but I kind of wanted to keep it stupid simple. So you're going to do number 5 and number 6. I will add some more problems with just like the basic numbers once we do a couple where we have variables. So I'll give you a worksheet or a quizzes over just the numbers with some that have the variables in them. Like if you look at 7 and 8, we will do some like that, but I wanted to get you guys familiar with just the numbers first. So again, we're doing 5 and 6. And if you have questions about these 4 example problems that I did, please feel free to reach out to me before we move forward, just so that you don't get lost in the shuffle.